Picture a remote region where nothing appears to be happening, and then, at regular intervals of 44 minutes, a strong signal suddenly appears, remains active for about 2 minutes, and then disappears again. The signal does not behave randomly or irregularly, but follows a precise and repeating pattern. Its origin is unknown, and there is no obvious mechanism that explains why it turns on and off in this way. This description is not hypothetical. It closely reflects what astronomers have recently observed within our own galaxy. Somewhere in the Milky Way, about 15,000 light-years from Earth, a mysterious object called ASKAP J 1832-0911 is sending out powerful bursts of radio waves, and remarkably, X-rays, on a clock-like schedule that defies everything astronomers thought they knew about how cosmic objects behave. It is not just unusual. It is so strange that even the theories designed to explain the universe's most extreme objects are struggling to keep up. This discovery, made by astronomers at the International Center for Radio Astronomy Research, ICRAR, in collaboration with scientists around the world, does not simply add another oddity to the astronomical catalog. It opens a new window into a class of cosmic phenomena that may be far more common and far more important than previously imagined. To understand why ASKAP J 1832-0911 is so extraordinary, we need to begin with how it was found. Modern astronomy is no longer just about looking at stars through optical telescopes. Instead, scientists listen to the universe across many channels, much like tuning into different radio stations. Some telescopes listen for radio waves, others detect X-rays, gamma rays, or infrared light, each revealing a different layer of cosmic activity. In this case, the initial detection came from the Australian Square Kilometre Array Pathfinder, or ASKAP, a powerful radio telescope located on Wajari country in Western Australia and operated by CSIRO. ASKAP is designed to survey enormous portions of the sky at once, acting like a wide-angle microphone for the universe. While scanning the sky, ASKAP detected something unusual. A source that switched on emitted a strong burst of radio waves for about 2 minutes, then vanished, only to return again after 44 minutes. This pattern repeated with uncanny regularity, like a heartbeat that refused to speed up or slow down. Objects that behave this way belong to a recently discovered category known as long-period transients, or LPTs. Unlike pulsars, which can flash many times per second, LPTs operate on timescales of minutes or even hours, making them incredibly difficult to detect and even harder to explain. But ASKAP J 1832-0911 had another surprise waiting. By itself, the radio signal would have been intriguing enough. But science sometimes advances not through careful planning, but through astonishing coincidence. At the same time ASKAP was observing this patch of sky, NASA's Chandra X-ray Observatory, a telescope with a very narrow field of view, was also pointed in exactly the same direction. This is where the discovery turns from unusual to extraordinary. When researchers compared the data, they realized that the radio bursts from ASKAP J 1832-0911 lined up perfectly with flashes of X-rays detected by Chandra. This marked the first time in history that a long-period transient had ever been observed emitting X-rays. Dr. Andy Wong, the study's lead author from Curtin University's node of ICRAR, described the moment with an image that captures the improbability of the find. Discovering the X-ray emission was like finding a needle in a haystack. ASKAP surveys vast areas of the sky, while Chandra looks at only tiny regions in extreme detail. That both instruments caught the same object at the same time was sheer cosmic luck. But luck alone does not explain the importance of what they found. To appreciate why X-ray emission matters so much, imagine comparing a candle flame to a welding torch. Both produce light, but the energies involved are worlds apart. Radio waves are the gentle whispers of the electromagnetic spectrum, while X-rays are its screams, signals that require violent, energetic processes to produce. Any object capable of generating both radio waves and X-rays must be doing something extreme. It must involve intense magnetic fields, powerful gravitational forces, or matter being accelerated to extraordinary speeds. This immediately rules out many ordinary explanations and forces scientists to rethink what kind of object ASKAP J 1832-0911 could be. Until now, LPTs were known only as radio sources. The discovery of X-ray emission provides a crucial missing puzzle piece, offering constraints that any future theory must satisfy. In science, constraints are invaluable. They narrow the field of possibilities, turning speculation into testable hypotheses. Astronomers are cautious by nature, and for good reason. Rather than declaring a single explanation, they explore several possibilities, each more exotic than the last. One leading idea is that ASKAP J 1832-0911 could be a magnetar, the ultradense core left behind after a massive star explodes. Magnetars are neutron stars with magnetic fields trillions of times stronger than Earth's, capable of twisting space itself and releasing enormous amounts of energy. They are among the most extreme objects in the universe, and they can emit both radio waves and X-rays. However, magnetars typically spin much faster than the 44-minute cycle observed here. Explaining such a slow, regular rhythm stretches current models to their limits. Another possibility involves a binary star system, where two stars orbit each other in a gravitational dance. In this scenario, one of the stars could be a highly magnetized white dwarf. The compact remnant of a low-mass star like our Sun. White dwarfs are less extreme than neutron stars, but under the right conditions, they can still produce powerful emissions. Yet even this explanation struggles to account fully for the precise timing and intensity of the observed signals. As Dr. Wang himself noted, even the best existing theories do not fully explain what astronomers are seeing. This raises a tantalizing possibility. ASKAP J 1832-0911 may represent a new class of cosmic object, or require new models of how stars evolve and release energy. In other words, the universe may be revealing a behavior we did not know it was capable of. One of the most exciting implications of this discovery is not just what ASKAP J 1832-0911 is, but how many similar objects might be out there. Since the first LPTs were identified in 2022 by ICRA researchers, astronomers around the world have found only 10 examples. That may sound small, but in astronomy, rarity often reflects observational difficulty rather than true scarcity. Professor Nanda Ray, a co-author of the study from Spain's Institute of Space Science and IEC, emphasized this point. Finding one object emitting both radio waves and X-rays suggests that many more are waiting to be discovered. We simply have not been looking in the right way, or with the right combination of instruments. It is like realizing that a forest is full of nocturnal animals only after you turn on a flashlight at night. The animals were always there. We just lacked the means to see them. The 44-minute cycle of ASKAP J 1832-0911 is not just a curiosity. It is a clue. In astronomy, timing often reveals the internal mechanics of an object. Just as the ticking of a clock reflects the motion of its gears, cosmic rhythms reflect rotation, orbit, or magnetic processes. The fact that this object turns on and off so cleanly suggests a stable, repeating mechanism, not a chaotic explosion or random flare. Something is acting like a cosmic metronome, regulating the release of energy with astonishing precision. This regularity is one of the reasons scientists find LPTs so puzzling. Most extreme cosmic phenomena are messy and unpredictable. Here, instead, we see discipline and order where we least expect it. This discovery also highlights how modern astronomy has become a global endeavor. No single telescope, no single country, and no single discipline could have uncovered the full story of ASKAP J 1832-0911. Radio astronomers, X-ray specialists, theorists, and data analysts all contributed their expertise. In many ways, the object itself mirrors this collaboration. It emits across multiple wavelengths, forcing scientists to combine perspectives and techniques. The universe, it seems, rewards cooperation. ASKAP J 1832-0911 does not yet have a final explanation, and that is precisely what makes it so valuable. Science advances most rapidly when nature surprises us, when observations refuse to fit neatly into our expectations. This object challenges existing models, expands a newly discovered class of phenomena, and hints at unseen populations scattered throughout the galaxy. It reminds us that even in a universe studied for centuries, entirely new behaviors can still emerge. 15,000 light-years away, something is flashing like a cosmic beacon, sending out whispers and screams across space. We do not yet know who, or what, is holding the switch. But by listening carefully, across every frequency available to us, we are beginning to understand that the universe still has many secrets left to tell. And sometimes all it takes to uncover them is being lucky enough to look and listen at the right moment.